The Space Telescope at James Webb captured something truly amazing: lights that seemed to emanate from a city, shining from a distant point for light years away. This finding has rekindled interest in the possibility of extraterrestrial life. Though, case of the telescope was centered on Proxima Centauri b, the closest exoplanet to the solar system. It found bright, enigmatic flashes of mystery, signs of an alien civilization. Stay tuned for more. For a very long time, scientists and ordinary people alike have been eager to imagine what life beyond our planet might be like. Any evidence from science pointing to something beyond has always been met with enthusiasm. Then came a turning point. When the James Webb Space Telescope was launched, it provided clear evidence of life somewhere in the cosmos. While scanning this potent force from the depths of space, the telescope detected something fascinating on Proxima Centauri b, a distant exoplanet. It observed lights similar to those of extraterrestrial cities, raising the possibility that an alien civilization exists on that distant planet. This idea has sparked a lot of excitement and curiosity among scientists, who are intrigued because such a discovery could be one of the things they've long been looking forward to. It suggests that there could be intelligent beings beyond our current understanding, organizing their societies in ways we are just beginning to discover. Looking at these distant, city-like lights found for light years away, NASA engineers are amazed and wonder how long they have been visible out there in space, awaiting our technology to evolve enough to detect them. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as particularly complex. This is because, unlike most rocky planets that absorb sunlight and emit energy in the form of infrared, this exoplanet exhibits a different behavior due to its unique relationship with its parent star, Proxima Centauri. This discovery, made by the James Webb Space Telescope, underscores its importance. The telescope's ability to capture infrared wavelengths was instrumental in detecting the unusual behavior of Proxima b, which is crucial to understanding the atmospheric conditions of this planet. Researchers intend to keep using this telescope to explore the planet's atmosphere in depth and even investigate whether it might be habitable. The James Webb Telescope is especially sensitive to infrared light, which allows it to observe what's happening on Proxima Centauri b at night. For many telescopes, it is difficult to discern faint light in the vast void of space, but the James Webb Space Telescope is able to pick up even the faintest glimmers. This makes it an ideal tool for confirming whether the alleged city lights on the far side of Proxima b are real. The telescope can detect artificial light in space. It is within a very narrow frequency band that is much narrower than the light emitted by normal stars. Proxima Centauri b has a dynamic relationship with its star. One side of the planet captures the star's intense energy, and its spectrum also reflects light. As the planet revolves, it traverses Proxima Centauri. It's undergoing a day and night cycle similar to that of Earth, with high temperatures during the day and cooler temperatures at night. The temperature of the planet varies mainly due to its composition. For example, if Proxima b lacks an atmosphere, the temperature differences between daylight and darkness would be extreme. Without the moderating effect of oceans or atmospheric gases, the day would get very warm while the night side would cool to sub-zero temperatures. This dramatic thermal variation is a subject of great interest to astronomers, as it offers clues to the atmospheric composition of Proxima b. The James Webb Space Telescope, with its unique ability to image in the infrared spectrum, can effectively analyze the planet's thermal emissions, providing valuable information about its atmospheric properties. Interestingly, the James Webb Telescope's orbit around the Earth coincides with Proxima b's orbital period, making detailed observations of its daylight cycles possible every 11.2 Earth days. The next step, if the planet has an atmosphere, will be to examine its chemical composition to determine its ability to support life. Signs such as the presence of oxygen, water vapor, and methane would be indicative of habitable Conditions. If these elements are detected, it would confirm the planet's potential to support life. This would involve analyzing the light passing through the planet's atmosphere, a complex task. Although the James Webb Telescope is excellent for describing planetary atmospheres, it is primarily designed for other functions. It specializes in analyzing variations in the concentrations of water vapor, carbon dioxide, and methane. Despite its limitations in detecting free oxygen, a vital indicator of life's telescope can also search for other important elements, such as ozone, which indicates a healthy atmosphere. As scientists examine the data from the James Webb Telescope, the search for distant worlds continues, increasing our proximity to uncovering life beyond Earth. Determining whether we are the only ones in the universe or not. It is critical to remember that the James Webb Telescope can observe only a limited number of exoplanets closest to Earth. For more detailed atmospheric studies, astronomers will turn to ground-based observatories such as the Extremely Large Telescope (ELT), which will begin operations in 2028. The ELT is designed to offer a deeper look at the atmospheric structures of distant exoplanets, providing clear and detailed data on their potential to harbor life. Scientists look forward to how future space telescopes like the ELT will function. In the meantime, the James Webb Telescope remains a crucial tool for the exploration of distant exoplanets. Despite its limitations, the James Webb Telescope continues to provide valuable information that could transform our understanding of what exists both now and beyond our solar system. Moreover, researchers have significant plans for the space telescopes of the future. They want to develop technologies that reduce starlight for better observation of the planets around them. It is like using your hand to block out the sun and see better. By dimming starlight, these future telescopes will be able to study the faint light reflected by exoplanets more clearly, helping to analyze their atmospheres and determine if they may harbor life. However, this task remains a considerable challenge. Blocking starlight to observe exoplanets is easier said than done. Stars are incredibly bright, often outshining their surrounding planets by orders of magnitude. That makes it difficult to detect the faint light that planets reflect. Light, which is essential for studying their characteristics. To tackle this problem, scientists are developing several innovative techniques. One such technique is the use of coronagraphs. These devices are placed inside the telescope and are designed to block out the starlight, while allowing the light from the planets to pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the star's glare, making the dim light from exoplanets more detectable. Another promising technology is the Starship Giant, flower-shaped spacecraft that flies in formation with the telescope tens of thousands of kilometers away. The star shade prevents starlight from entering the telescope, allowing only the light from exoplanets to reach the instruments. This method could be particularly effective in observing planets in the habitable zones of their stars, where liquid water and potentially life might exist. These technologies, however, require an extraordinary level of precision. The alignment of a star shade, for example, needs to be perfect down to fractions of a millimeter over vast distances. Moreover, these advancements must overcome the limitations of space missions, such as the need for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these obstacles, the potential rewards are immense. Successfully observing and analyzing the atmospheres of exoplanets may result in the discovery of biosignatures, chemical evidence of life. Molecules like oxygen, methane, or water vapor in specific ratios could hint at biological processes, suggesting that life might exist beyond Earth. Researchers are also exploring ways to directly image these distant worlds in greater detail. Future telescopes may be outfitted with advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or telescope movements, producing sharper images. Combined with methods for blocking starlight, these improvements could allow scientists to go beyond just finding exoplanets. They could map their surfaces and study their environments. The evolution of these next-generation space telescopes represents a leap forward in our quest to answer one of humanity's most entities. And we all know I've been exploring that most entities, and we all know I've been exploring that path. They could map their surfaces and study their environments. I can't make what we can't map electively, my Mac of Wascase. My evolution of an MYW slash compatic keiki dot wall quote. ATOTS canna K slack. Quo I can't we see with you at Quay Kanayat K we katita we can to see with Siki Kian do we see? Profound questions. Are we alone in the universe? By redefining our ability to observe distant planets, we edge closer to determining whether life exists beyond Earth. It's potentially revolutionizing our understanding of our place in the cosmos. Let me know what you think in the comments box below. If you liked the video, remember to like and subscribe, and I'll be seeing you in the next video.